Okay, I will now begin today's session with a brief introduction. Welcome everyone to the IEA Bioenergy Webinar series hosted by the Canadian Institute of Forestry. My name is Ronnie Huang and I'll be moderating today's session. Today is September 14th, 2017, and we are very pleased to have Elina Hakkarainen, who will give a presentation on Integrated Bioenergy Hybrids, Flexible Renewable Energy Solutions. To start things off, Ms. Elina Hakkarainen is a research scientist at VTT Technical Research Center of Finland and holds a master's degree in renewable energy production. Her work covers dynamic modeling, simulation, concept development, and evaluation of renewable energy and renewable energy hybrid technologies. Her specific interests include solar energy production and applications, energy transition, and the role of renewable energy hybrid technologies in the low-emission energy system. She completed her master's degree in the field of concentrated solar power and hybrid technologies, and she is currently working towards her PhD at the La Piranta University of Technology. With that, I will pass it along to Elina to start off the session.
So, good evening, or good morning if you happen to be in a completely different time zone, and welcome to this webinar also on my behalf. So I will be talking today about integrated bioenergy hybrids, and this is especially from the point of view of hybrids being a flexible renewable energy solution and bringing flexibility in the energy system, which we need when we move towards a low-carbon energy system. This presentation is mainly based on the results from the project which we ran last year under IEA Bioenergy Task 41. And actually in the beginning of the presentation, I will give you a very short overview of this project. And after that, I will jump back to the actual topic and explain a little bit about the backgrounds on these hybrids. So why are we even considering integrated bioenergy hybrids, in what kind of context are we studying them, and how have we defined integrated bioenergy hybrid? The main focus in this presentation is in case examples which we defined during the course of the project, and with these examples I will also try to explain the benefits offered by different hybrid concepts and what is the role of bioenergy in different hybrid concepts. In the end of the presentation, I will also present some key actions which we have suggested during the project for the next 5 years in order to support the investments in bioenergy hybrids. So, as I told, we run this project called Bioenergy RES Hybrids under IEA Bioenergy Task 41 as a special project last year. And in the project, we surveyed the status of bioenergy utilization as a flexible element in hybrid processes. And this survey was done by screening ongoing R&D projects and operating hybrid systems in case study countries. And in addition to this, we also considered the future development potential and role of hybrids in the energy system. The case study countries in the project were Finland, Germany, and Austria, and we had partners from all of these countries taking part in the project. And in addition, also we got some contribution from IEA Bioenergy and European Commission. And in the project, we look at the hybrids in different energy sectors, heating and cooling, power, and transportation. The main outcome of this project was published as a report called Integrated Bioenergy Hybrids, Flexible Renewable Energy Solutions. And this publication can be found in the IEA Bioenergy website. The website address is given in this slide. But then we will move back to the actual topic and to the background. So as we all know, our energy system is currently in transition towards a system that relies more and more on renewables. And these renewables are mainly solar and wind power, and their costs are increasingly cost competitive with the fossil-based generation. These resources are dominantly abundant, but we also have to remember that they are variable by nature. At the same time, then solar and wind power are increasing. In OECD countries, the electricity demand is stagnating, and this means that there is only a little need for replacing the existing grid infrastructure and generation capacity. The existing capacity is designed to operate as baseload units. So when the variable renewable energy generation increases in the system, this sets pressure, both technical and economic, on the existing capacity. For example, when we have more variable generation, the capacity factor of the existing capacity decreases. And also when we have energy supply, both from the variable generation and from the existing capacity, we might start to have oversupply of electricity, and this tends to decrease the wholesale prices of electricity, which is further a challenge for the existing capacity. So the key question of today is, how can we maintain a reliable energy supply while at the same time meeting the emission targets we have set? These figures demonstrate the very fast growth rates of solar PV and wind power. These are global figures, but the same applies also in the European level. And we should not only focus on the power sector, we should also look at the heating sector, where solar thermal energy is a variable renewable resource. In recent years, the solar thermal growth rates have been slowing down, but there are also some exceptions. For example, in Denmark, we have seen really incredible growth rates in recent years. This figure here shows the power plant investments in European Union from 2000 to 2015. And we can see the net installed and decommissioned capacity in gigawatts for different energy resources. And what we can see as the main point is that wind, gas, and PV forms the big three in investments. Wind and solar PV are variable resources, and gas is a very good and low-cost balancing source, bringing flexibility to the system. But if we want to meet the long-term climate change mitigation targets agreed in Paris, no energy system can actually rely on a fossil fuel backup strategy. So this means that we have to look at new kind of solutions to bring flexibility in the system. And one option is biomass. And it's by nature storable and dispatchable resource, able to bring the flexibility needed. So it's quite clear that there is demand for low carbon technologies which can balance the differences between energy supply and demand. According to Bloomberg, over the next 25 years, so until 2040, there will be investments in the power generation worth of $11.4 trillion. And what's more important is that of this amount, as much as $7.8 trillion will be in renewables. Now we have been talking a lot about power sector, but we really shouldn't forget the heating and cooling sectors. And why is that? It's because today heating and cooling represents about half of the EU's annual energy consumption. And of this amount, we still produce a lot of heat from fossil resources, mainly natural gas and solid fossil fuels. So the replacement potential is quite big. Today, approximately 1/5 of the heating is produced by renewable energy sources, and if we look more closely at this number, we can see that bioenergy is already playing quite a big role there. So what kind of flexibility resources do we need, and what kind of options do we even have? Recent IEA's report defined 5 different types of flexible resources, and these are grid infrastructure, dispatchable generation, demand-side integration, storage solutions, and operational flexibility as a cross-cutting issue. And And in our project, we thought that with bioenergy, we can mainly find flexible solutions in terms of dispatchable generation and storage solutions. So these are where we have focused on in this project. In the project, we saw that there are a really wide variety of different hybrid solutions. And in order to decide which we will consider and which not, we had to give a definition for the integrated bioenergy hybrid. We came up with two different definitions. The first one is that integrated bioenergy hybrid is an energy conversion process that has at least two energy inputs, one of which is bioenergy. And as we can see from the definition, this kind of hybrid system can have both renewable and non-renewable resources. And if we want to have, if we want that bioenergy hybrids can meet the long-term climate change mitigation targets, we should leave out the fossil resources. And if we leave these out, we can talk also about bioenergy RES hybrids. And in this project, we mainly focused on these kind of hybrids, leaving out the fossil resources. So why should we even integrate different energy sources? The main idea behind the hybrid system is that it is designed in such a way that we can use different energy sources to their fullest potential and overcome limitations related to using single energy sources alone. So we can summarize this idea so that the whole is greater than the sum of its parts. With hybrid systems, we can achieve different benefits in different levels of the system. In the process level, we can, for example, improve the process efficiency and gain some cost benefits. In the system level, we can improve the flexibility and reliability of energy supply and increase the biomass resource efficiency. In the societal level, we can improve the security of energy supply and also have some positive environmental impacts. And these impacts can be easily defined, for example, the process efficiency and the cost benefits. But some of the impacts are more hard to define. For example, it's hard to define the gains in flexibility and reliability. And before going to the case examples, I want to show how we have classified these different examples. So the classification in different hybrid solutions is done based on the applications and the scale of the hybrid system. And we ended up in 5 different groups, which are domestic, farm scale and industrial applications, utility and district applications, and biomass-based storage solutions. And next I will provide you some case examples from most of these groups. So we can start with domestic hybrid solutions. And in households, bioenergy is a very traditional energy source, but bioenergy is not only a traditional technology, it's also a technology of today. However, the role of bioenergy in households has changed over the decades. So today, bioenergy is seldom the only heat source in the household, but it's usually combined with some other heat sources. And actually, in domestic scale, hybrid heating systems are a standard technology today, and they are mainly found in the heating sector, and the largest potential is outside the district heating networks. The integration of different energy sources is very flexible and robust, thanks to the heat storage tank, which is usually integrated in the system. In the small household scale, biomass and ground source heat are typically considered as alternative baseload options, and biomass and solar thermal are already a standard combination, for example, in Germany and Austria. In Germany, approximately 60% of all pellet boilers and stoves are already combined with solar energy. In Finland, these kind of systems are in the stage of entering the market. The investments in hybrid systems in household scale are today fully market-driven, and the main challenge is for example, the selection and proper dimensioning of the components. So I don't focus more on the domestic scale heating systems because they are already quite a standard technology. But next we will move from the household scale to a large district scale hybrid systems. The district heating platform of Helsinki area in Finland is a very good case example of an efficient urban large-scale hybrid system, or it can be called a hybrid platform. And for example, the system in Helsinki aims to be a carbon neutral energy system by 2050. In the district heating and cooling networks, there is a very high potential for renewables, and the expansion of district cooling system further increases this potential. In the system, biomass is the very fast way to increase the share of renewables, and in Helsinki this is done in different ways. For example, there is co-combustion of wood pellets and coal, there is distributed heat generation based on biomass, and the local energy company also provides biogas products for the district heating customers. Then if we use also other renewable heat sources, we can in the future shift the bioenergy use also for the other end uses than energy. In Helsinki, there is, for example, used a heat pump station which produces heating for the district heating network, but it also produces at the same time district cooling and covers the heat from the cooling system back to the energy system. The heat pump station also utilizes energy sources that would be otherwise unutilized. For example, heat is recovered from the purified sewage water plant to the district heating system. Next we have an example which is actually a benchmark from Denmark, where it's already quite common to combine in a single district heating site different energy sources, mainly biomass and solar energy. A typical combination includes wood pellet or wood chip boiler and solar thermal energy. And with the help of solar thermal energy, the biomass boiler can be shut down for the summer period. And this gives the benefit of a longer maintenance period for the boiler, and also the part loads with low efficiencies can be avoided during the summer period. The system usually includes also a heat pump, which allows very efficient utilization of the solar thermal energy. In addition, there is also typically heat storage tanks and natural gas as a backup in the system. Typical annual solar production in these kind of systems is in the range of 20 to 30%, but it highly depends about the sizing of the solar field and the heat storage system. This kind of system can sound quite complex, but with the proper optimization of the operations and the control system, quite high system efficiencies can be achieved. In Denmark, the solar district heating in general has been increasing rather fast, and today there is in operation already over 100 solar thermal district heating plants. Solar thermal is seldom their only heat source, so this gives quite large potential for hybrid district heating systems. This is a little bit similar example of a regional heating system from Gleisdorf, Austria, where biomass and solar thermal energy are combined to produce heat for an office building and several low-energy houses. About 50% of the heat is produced by solar heat and the other half with wood pellet boiler. In addition, there is a central heat storage tank of 14 square meters in the system, and it provides the space heating for all the buildings. The other innovation in the system is that the heat distribution network can be operated at 2 different temperature levels. And this means that during the night, for 2 hours period, the system is operated at a much higher temperature level to provide domestic hot water at 65 degrees C for the decentralized storage tanks, which are located in each of the buildings. And actually, these kind of demonstrations can be found much more already in Austria and Germany. In Finland, these kind of solar district heating and hybrid systems are still quite seldom in Finland. But this example is about the first pilot-scale system combining biomass and solar energy in a hybrid system in Finland. And this system aims to replace the fossil fuel consumption of the regional heating system. And the hybrid system includes wood pellet boiler, solar thermal collectors, and an electric heater. The system doesn't have any heat storage tank because in this way the investment cost can be minimized, but as a consequence also the annual solar share remains quite low. Then we will move to the industrial scale applications. And in industry, the renewables have been increasing in recent years, and some sectors where we have seen the growth are, for example, food and metal processing industries, textile, beverage, and mining industries. In industry, the main drivers for the investments are to increase the security of supply and decrease the energy-related costs. And the hybrids can be mainly found in the heating and cooling sector, where we have several options to produce the energy. And well, when in household scale, so in small scale, bioenergy and ground source heat are typically alternative options. In a larger industrial scale, they can be also combined easily. In industry, there is a lot of potential for waste heat recovery and different process integrations, which are also an efficiency action. Solar heat and electricity are good options since they have quite nice match with the industrial cooling demand. One example of the hybrid system is shown in the figure, which is about a slaughterhouse in Austria. And in this system, 80% of the heat demand is produced by CHP plant, which uses biogas, and the rest of the heat demand is covered by ground source heat. And the biogas is produced from animal byproducts of the slaughterhouse. In general, biogas is quite nice energy source because it can be used quite flexibly for heating, power, and mobility. And in addition, it can create new local networks and businesses between the stakeholders of the area. Another example from industry are virtual power plants and power-to-gas concepts. These kind of concepts typically combine biogas and biomethane with wind power. And there are already quite many demonstrations taking place in Germany, and the technology is very close to the market entrance there. The figure shows one example, which is an Enertrag virtual power plant located in Prenzlau in Germany. And it's quite common way how the components are connected. So there is surplus wind power, which is converted into hydrogen, and this hydrogen can be combined with biogas production. And this kind of system serves the heating and power and also the needs of mobility sector. And actually this kind of system can be considered as a chemical storage of variable renewable energy in the biofuels. And this kind of system provides flexible storage options, but also brings resource efficiency for the biomass use and can give ancillary services for the power grid. The last example is about a long-term energy storage solution. And in this solution, solar thermal energy is stored in solid biomass. And we can also call this solar enhanced drying of solid biomass. And if we try the biomass in decentralized manner in the production sites, for example in farms, we can create new business opportunities, for example for the rural area. And in order to study this concept more, we have installed a pilot system at VTT's office in Jyväskylä in the central of Finland. And there we have 2 solar thermal collectors on the rooftop of the office building, and inside we have the biomass dryer. And the solar thermal collectors can provide heat both for the biomass dryer, but also for the device for direct air capture of CO2. And with this kind of system, we can study the efficiency, controllability, and economics of this kind of system. With this kind of concept, we can get many benefits. We can have a low-cost and long-term storage application for solar energy, and this is quite important because typically the solar energy production has a mismatch with the heat demand. In addition, we can provide good quality biomass for different thermochemical conversion processes. We can avoid the dry metal losses in biomass and also enhance the efficiency of the biomass logistics because we can avoid transporting wet biomass thanks to the biomass drying in the production sites. So now I have presented some current case examples of bioenergy hybrids, but in the project we also looked at the future development potential, and these results are gathered in the publication in the form of table, or they are summarized there. I won't go in more details in this, but you can check these results in the publication. Also, if you want to learn more about the existing hybrid applications and find more details, you can check the 3 country reports which we also produced during the course of the project. So there are own reports for Germany, Finland, and Austria, and this can be also downloaded in the IEA Bioenergy website. The next question is, how can we realize the benefits which the hybrid systems can offer? And for this, we suggested some key actions, 6 key actions for the next 5 years, which we could use to support the investment in hybrid systems. And as the first key action, we suggest to create an online knowledge library, and this is to share information on successful case examples of hybrids and best practices related to these. We already know that bioenergy hybrids are quite common in household scale, but we also have many good case examples in larger scale, and these are especially the cases we should focus on in this knowledge library. As a second action, we suggest to develop methods to assess the economic feasibility of hybrids. The feasibility of hybrids is very case specific, and it highly depends on the value of flexibility. Today, there are no simple universal methods to assess this value of flexibility, so we also should look at this more closely. As a third action, we suggest standardization of hybrid system interfaces. This is already done to some extent in the household scale, but we could achieve quite significant cost benefits if this would be done also in a larger scale. As a fourth action, we suggest to develop optimized control systems for hybrids so that we could better manage the energy production from different sources and also take into account, for example, weather and market conditions. As a fifth action point, we suggest to improve the flexibility of bioenergy technologies, and this covers, for example, lower minimum loads and higher maximum loads of the boilers, faster load change rates, and local startup and shutdown procedures. The sixth and the last action point is developing novel integrated bioenergy hybrid concepts. As we know, the future energy system is likely dominated by variable renewable energy generation, And because of this, we need better understanding where we should use the biomass and what kind of hybrids are the winning technologies. So we should focus on these with the development. And with these actions, I will end my presentation, and I hope you to be in touch if you have some good ideas on these hybrids for the future. Thank you.
All right, thank you very much, Alina. That was fantastic. So I will now unmute the lines for a question period. So one moment, please.
The leader has turned lecture off and your lines have been unmuted.
So to ask a question over the phone, please state your name, where you are calling from, and then address the question. We also recommend directing any questions towards the chat pod in the middle of the section where you can type in any of your comments or questions, and then we can address them one by one. So the floor is now open for any questions. Yes, so for the what we do is we can send out the PDF file, so if you can leave an email in the chat pod, I can do that. Also, multiple people can be typing at the same time, so feel free to type in any comments or questions for Alina right now. Seems like most people are just leaving their emails for, yeah. Okay, that's okay.
I will get a nice email list.
So I'll leave the chat pod on for you, Alina, so you can maybe copy down the emails.
Yeah.
Okay, so we actually have a question from Michael. Could you please elaborate on what biomass sources were incorporated, such as first, second, and third generation biofuels? That's from Michael. Alina?
Sorry, I was reading the question. So
okay.
We mainly focused on the solid biomass, like on the flexibility of biomass boilers, so wood chips, pellets, and so on. And in the liquid biofuels, we didn't look so closely about the end product, but mainly on the process, what kind of components we could combine.
All right, thank you. So we have a couple of comments. Thank you for the great presentation. Thank you for the clear presentation and many nice practical examples of hybrids in action. Okay, we have a question from Tom. Are you developing a public database of hybrid bioenergy systems? So that's a question from Tom.
That's one of the actions we suggested, so we are not yet doing that, but that would be really interesting next step, and I think that would be like very beneficial for many different stakeholders and parties, like companies, research institutes, and so on. So that should be really done in the future, but at the moment we are not doing that yet.
Okay, we have another question from Gary. Do you see liquid biofuels as a possible storage option? That's from Atlanta, USA, from Gary.
Yes, we see the liquid biofuels as storage option since, well, they are a storable media and they could be used to balance the imbalances between the demand and production.
Okay, thank you. Our next question comes from Dildeep. Can you somehow relate to the emerging biorefineries, also bio-based economies with hybrid bioenergy systems?
If I get the question right, I would say yes, because like the new biorefineries themselves are kind of a hybrid systems, especially if we combine them with variable energy production, like using the excess production from wind or solar power.
Great, thank you. Okay, we have a couple more questions coming in. So one from Keith. So does a hybrid system have a better climate or greenhouse gas reduction performance than bioenergy systems on their own?
Well, this of course depends how we handle the emissions from bioenergy, but when we combine bioenergy with other heat sources, we can reduce the bioenergy consumption itself, which makes sense for everyone, I think. Like if we need to produce the same amount of energy and we replace part of the bioenergy, we can end up in reduced bioenergy consumption. But one of our studies where we combined concentrated solar power and bioenergy also showed that with this kind of combination, we can also improve the efficiency of the process, and that also partly leads to the reduction in bioenergy consumption and in emissions.
All right, thank you very much. Our next question comes from Donatella. In the considered cases, what have been the share, so in terms of percentage, of bioenergy?
Well, there are a really wide variety of different bioenergy hybrids, so it's a little bit hard question to answer shortly. But for example, as I saw one slide in Denmark, where they combine many different energy sources, I would say that the typical bioenergy contribution is much more than 50%. In the case where we combine concentrated solar power and bioenergy, we could achieve something like 20 to 30% solar share, and the rest was bioenergy. But this really highly depends on the case.
All right, next question comes from Alex. What are the main woody species being used as biomass sources?
In our concept and system screening in the project, we didn't go so much in details. So we just considered that, okay, we have, for example, solid biomass.
Okay, so maybe just a couple more questions in the interest of time, so we'll finish off the ones that are already posted right here. So another question from Dilip. What is about the efficiency of the hybrid bioenergy systems? Seems like a broad question here.
Yeah, I think it's really hard to answer at this point because we looked at so many different hybrid systems, but like if the bioenergy is the main energy source, I would say that the efficiency where we end up highly depends about the starting efficiency of the bioenergy solution.
All right, thank you. So a follow-up thank you from Keith. And then our next question is from Michael. What are your thoughts on renewable energy sources becoming the denominating source of energy for the heating/cooling sector, as they have the potential to phase out fossil fuels as society makes this energy transition?
Yeah, actually, I think like the heating and cooling sector is the most easiest way to increase the renewable share and phase out the fossil fuels. So I think the question is already answered in the question. But yeah, there is, like I showed one diagram, there is a really great potential in the heating and cooling sector. And for example, in the district heating systems, the integration of different heat sources is easy because the system itself is kind of neutral for the heat source.
All right, thank you. Next question is from Gary. Do you see growing biomass resources as an economically attractive option?
I guess yes, but like one approach in this study was that when we go to the hybrid systems, and phase out the fossil fuels, in the end we can start to replace also biomass in the future and use that also in the other end products, which might have a higher value than energy.
Right, so follow-up comment from Donatella. Many thanks for the answer, so thank you very much. We have time for maybe one last question. So I'll leave the floor open for one last opportunity, one or two. So just wait for a moment here for allow people some time to type in any comments or questions. Okay, so maybe your last question will be from Sung Chang. So, okay, question from Luke. Do you see a competition with smart grids?
Well, I cannot say that I see there a direct competition. I see that these are more like supporting technologies or approaches. Like smart grids also relate, for example, to district heating systems.
Okay, I think this might be our last question from Michael. What are your thoughts on students in engineering looking to get into biofuel industry? So education, etc.
That's a hard question, but yeah, why not studying that?
Okay, so I guess in the interest of time, I would like to bring this session to a close. So thank you all very much once again for participating in today's webinar, and once again thank you very much to Alina for the wonderful presentation.
Okay, thanks all, and I really hope you will be in touch. My contact information is there in the slide, so if you have any ideas, just be in touch in the future.
All right, thank you very much. And this was the IEA Bioenergy Webinar series hosted by the Canadian